Hi, so today we're going to look at polynomial graphing. As a kind of a study guide, we'll take a look at what Khan Academy has for the unit test for polynomial graphs. And we'll take a look also, a brief look at Desmos and how you can use it to find zeros and vertices and y-intercept, x-intercept, all that sort of stuff. When you give a polynomial equation into it. So let's take a look. Okay, so our first question here on the unit test is all about adding points based on a polynomial equation that is given in factored form. So I want to find the zeros first of all. So the way to find the zeros is to consider first of all that this polynomial, right, is going to be 0. So this polynomial here is going to be equal to 0 if any of these terms, so if x plus 2 equals 0, or if 2x minus 3 equals 0, or if x minus 3 equals 0. So that's kind of what this is all based on, right? The zeros, the idea being that this is your y value, this is your p of x or your y value. So when you look at your graph, and we look at that in a moment, we'll notice that we're looking for the points on this graph where y is equal to 0. So where this p of x here is equal to 0. Okay. All right, so let's figure that out. So the easiest way to figure this out is actually just look at the factor. Okay, each of these are factors. We look at the factor and we basically just take the inverse of whatever the coefficient is, but it's not quite exactly like that, as you'll see with the second one. So the first one here is quite easy. For the first one, we would be looking at for x plus 2 equals 0. That implies that x equals negative 2, right? That's easy to determine. And for x minus 3, we'll look at that as well. So x minus 3 equals 0 implies that x equals positive 3. Okay, so you can see here we're just changing the sign. Okay, just one thing to look at with this 2x minus 3. We generally write factors in integral form here, but essentially what this means is that your x, your 0, is a fraction. Let's take a look at that. So for 2x minus 3 to be equal to 0, note that what you're doing is you're adding 3 to both sides. Right? You're back to your inverse operations, and you get 2x equals 3, or divide by 2, or x equals 3 over 2. Okay, so you can, the quick and easy way of doing that is looking at at what you've got here, change the sign and divide by the coefficient. Okay, that's the quick and easy way of doing it. So just change the sign and divide by the coefficient, and you've got your 0. Okay, we'll plot those and we'll be done with it. Okay, so the first one is negative 2 right there. The second one is positive 3. We got that one also. And our third one is 3 over 2, or 1.5. So there we go. Okay, next question. So we're looking at this polynomial function. We're looking at the end behavior of the function, right? So we're looking at what is happening as g of x, as x approaches, what happens to g of x as x approaches infinity, and what happens to g of x as x approaches negative infinity. So we're looking at the two ends of our x-axis. So what's happening all the way down here, and what's happening all the way down here. Right? Now, to determine that, there are two things we need to look at. We need to look at the leading coefficient. Right? The leading coefficient. There's two F's in there. And the degree. And we're less concerned with what they actually are than their characteristics. So recall that If we have well, let's look at the degree first. We have an odd degree, right? The highest exponent is a 9, so our degree is odd. That means that our two ends are going to be opposites. Essentially, one is going one way and the other is going the other way, right? If it was even, they'd both be going the same way. Our leading coefficient then is positive, right? Which tells us the right-hand side of our graph goes up. Okay, so the right-hand side of our graph goes up, and yeah, this has got a degree of 9, so it's going to have 8 bounces in it. It's going to bounce a bunch of times here, and then it's going to go down. Okay, so it's going to go in opposite directions because it's odd. The right-hand side is going to be going up because it's positive. So we're looking for g of x as x approaches infinity. G of x is going to approach infinity, and this is going to be opposites. So g of x is going to approach negative infinity, right? As it goes in the other direction. So we're looking for option D. It looks like here. So double check that. As x approaches infinity, g of x approaches infinity. As x approaches negative infinity, g of x approaches negative infinity, and we're done. Okay. So now we're looking at intervals. We're looking at the sign of the interval here. We often look in our assessments, we will look more at increasing and decreasing, but you can also find the sign of the intervals, right? So there's a few things you need to determine from here. The first thing here is your degree and your range, or your degree and your leading coefficient, because you need to know what the function looks like. So we've got 1, 2, 3, 4, 5 x's, so our degree is 5, x to the 5th, right? Which means they're going in opposite directions. None of these x's are negative, so we're going, what's happening here, let's draw it really quickly. We're going up on the right-hand side, okay, because it's got a positive leading coefficient, and they're going to go in opposite directions. So it's 5, 0, so we can say something along the lines of that it goes 1, 2, 3, 4, and 5, right? So 1, 2, 3, 4. 4 vertices is what it should look like. And now we're told that it has zeros at 1, 2, 3, 4, 5 zeros. So it crosses over the x-axis 5 times. So we could actually draw a line through here. All right, let's draw a line. Let's draw a line straight through here. Make sure we get through all of them. All right, let's say this is our x-axis. Okay, so our x-axis here, right, crosses over 5 times. And it really doesn't matter what these points actually are, but we want to be able to identify those two there. Okay, so what we have is we have a point here. Let's say this is going to be whatever the lowest one of these is. So that's going to be -5. Then our -4 is going to be here. That's -4. Right. Again, this is not to scale. Right. And then we got 1, 2, and 9. So this one here is 1, 2, and 9. Right. So all we're asked to determine is this interval here. All right. We're asked to determine from -4 to +1 what is, so this interval right here, is f of x positive or negative. Right. And you can see right there, it's always negative on that interval. And you'll notice as well, it's strictly, if it was equal to, they couldn't actually say that it's negative, it will be also equal to 0, right? But strictly less than 4, or sorry, strictly greater than 4 and strictly less than 1, that's our interval right there, and we're always negative on that interval. The same method can be used to determine increasing and decreasing. Okay, so here's a polynomial that has been graphed. We can see we can get a rough grasp of it just by looking. It looks like we've got 2 zeros here. It's bouncing off the x-axis right here. We've got okay, there's a second vertex right there, and it looks like we're curving here and going up here. So this one here, it's likely to be just because of the way it curves, rather than curving through kind of more smoothly, this looks like it might actually have a an exponent of 5 maybe rather than 3, but we'll take a look. So essentially we've got a factor here that we can give by our 0. Our 0 is -2 here, all right? So we've got that's probably the wrong color choice. We've got an x plus 2 squared certainly here. We've got it's right on the 0 here. So this is likely to be something along the lines of x to the 3rd or maybe x to the 5th, right? Just looking at how flat it is, but x to the 3rd if that's an option. Those are the zeros we have. So let's take a look at what are the options that we've been given. So that's these are possibilities of our graph right here. Okay. So you can see here we're looking, this one here is something that is a possibility for us, right? We said, okay, x to the 3rd is possible, and x plus 2 squared was our root. Certainly x plus 2 squared is our root. So our two options here with x plus 2 squared being our root, which we know to be true. That's the one we know absolutely to be true, right? Our two options here, we notice we've got an exponent of 3 or an exponent of 2. Well, the exponent of 3 goes through, whereas the exponent of 2 bounces off, and we can see here that it goes right through, so it must be what we must have here is x cubed times x plus 2 all squared. All right, so this would be our equation. All right. So that's basically finding the zeros first, and then determining what we can from there. Okay, so with this one here, we do need to do a bit of factoring first, right? Because we need to find the zeros before we actually put them in. Okay, so we'll deal with both sides separately, both factors separately. We've got a quadratic factor. We've actually got two quadratic factors here. If we look at this is just a difference of squares, because notice that this is your u squared minus v squared pattern, right? Okay, because this is actually 2 squared. So we can say that this is, we've got x squared plus 4x plus 3. We'll deal with that in a moment. And this one here, we notice this is a difference of squares. So this one here must be x plus 2, x minus 2. Right, so there's your difference of squares right there. Okay, so for this other quadratic right here, we're looking for the factors of 3 that add up to 4. Well, 3 and 1 will do, right? And they're all positive. So we've got x plus 3, x plus 1, x plus 2, x minus 2. So those are our 4 factors. So let's get our zeros from this. So we've got x equals -3, -1, -2, and +2. So those are our 4 zeros. Let's plug them right in here. So -3, -2, -1, and oh no, I've taken one. -3, -2, -1. Yes, -3, -1, -2, and +2. All right. So there's our zeros right there. Okay. Moving on, right? We're rolling through this. This is looking good. Okay. So we've got an equation here. We've our polynomial right here. We've been given the factors, and we've been told what the zeros are. Right. So this is nice for us. This is similar to what we looked at before. Okay. So. So let's take a look at what we've got. We've got 1, 2, 3, 4. We've got a degree of 4, which means that it goes off in the same direction. All of them are positive. So what we're looking at here as a graph, roughly, is we're looking at going. It's positive because all of these x's are positive, and it's got a degree of 4, so it bounces 3 times. So we're going 1, 2, 3. It's got 3 vertices, right? We're told it actually has 4 zeros, so we can draw our line. We can draw our line straight through all of these. So this is our x-axis right here, okay? And now we can start looking at those zeros. So the zeros in order, this is -3, so this is going to be the lowest one. So this one here is -3. This one here is -5/2. My apologies, let's fix that. -5, but -5/2 is -2.5, so -3, -5/2. It's early in the morning. And then we've got 10/3, which is 3 1/3, so 10/3. And we've got 4. So those are our 4 zeros right there. Okay, and the same sort of question we had before is what about what's this interval? -5/2 to 4. So -5/2 to 4. All right, so we're looking from -5/2 to 4. This is our interval here, and we see that it is both positive and negative on that interval. So it's not always. It's sometimes positive and sometimes negative on that interval. Okay. So there you have that one. It's similar to the previous one, just with slightly different characteristics on it. Okay, so we're told again, polynomial that has these particular zeros in it. So we've got 3. It looks like we've got 3 zeros here. So what could be an equation of this polynomial? So what we can do here is we can actually write this equation reasonably. So we can say, okay, we've got p of x, right, is equal to, well, remember I said before we don't particularly like saying that giving a factor with a fraction in it. So what we like to do, this is our coefficient of x. So we say that's 5x. Change the sign, so -1. There's one of the factors. And then we've got x plus 4, and we got x minus 2. So these are our 3 factors that we give. These are our 3 factors that we give based on that. Let's take a look at what the answers down here are. All right. So these are given with the signs. Remember, we changed the signs on all of them. Double check that. This is a change sign, change sign, change sign. So it's negative, positive, negative, right? And we also did what we need to. The coefficient is the denominator and the numerator is the constant. So we'll match up down here. We see this does not work. This one here does. 5x minus 1, x plus 4, x minus 2 is the one we're looking for. And of course, you could expand that out if you wanted to. All right, let's look at end behavior again. So end behavior, remember, we're looking at the degree and the leading coefficient. So the degree of a polynomial and the leading coefficient. All right, so the degree of this polynomial, if we look at it, is a 4, which is even. That means they're both going to go in the same direction. Right? The leading coefficient, if we look at it, there is a positive 3, so that's positive. So that means that the right-hand side goes upwards, right? Because the leading coefficient is positive. And they both go in the same direction, so this is actually going to have 3 vertices. It's going to go 1, 2, 3, and then it's going to go up here in the opposite direction. So this is roughly what it looks like. We can see as x approaches infinity, y also approaches infinity, and as x approaches negative infinity, y approaches infinity. So both times they both approach, or the q of x rather approaches infinity no matter what. Okay, so q of x approaches infinity, q of x approaches infinity. This here is our option right there. Okay, let's move on to the last question. So what we're going to do here is we're going to factor out this 5x. We're going to factor out any common factor that we have first. So the greatest, essentially the greatest common factor is what we're factoring out first. So we're going to factor out the 5x. So we now have 5x. So 5x cubed divided by 5x is x squared. 5x squared, or negative 5x squared, divided by 5x is negative x. And negative 10x divided by 5x is negative 2. All right, so we factored out the 5x. Let's now factor this quadratic here. So we've got our 5x on the outside. And the factors of negative 2 that add up to negative 1 are going to be negative 2 and 1. So we've got x minus 2 and x plus 1. So here's our three factors, and from there we can determine that x is equal to 0. That's one of the zeros, right? Because if this x here is 0, then it's all 0, right? X is going to be equal to positive 2, because if this x is positive 2, everything else is 0. And x is going to be equal to negative 1, again, because if this x is negative 1, everything else is 0. So using that, we can plot our points, and we can be done with this. So we've got a 0 right here on 0, on negative 1, and on 2. Okay. So once again, I do want to show you what this looks like when you get your report at the end. And if you've got any issues with any questions with Khan Academy, you can close out of your report, and then you can go down through your exercises and videos if you need to, and see how you do what you need to work on. And one last thing to look at here with, say, Desmos. I've got an equation in here, so I'm going to hide that equation real quick. Worthwhile for you to see that. And let's put in that last equation that we had. So we had a 5x cubed minus 5x squared minus 10x. So this is our equation right here that we got just a moment ago. All right, so let's zoom into the important part of this equation right here, and we can see a few things about it. Right, Desmos is great in this way. It gives you a lot of information. What we can do is we can click on this, and we'll see all these gray points here. So there's your zeros, the zeros that we looked at before. You can even find your local maximum and your local minimum, things that you'll need for your assessment, right? And you can see that it goes in opposite directions for your end behavior, right? So these are, and you can see your increasing intervals, of course, based on your local maximum and your local minimum. You can see your increasing and decreasing intervals, and whether an interval is positive or negative, and so on. So there's quite a few things that you can determine just from looking at Desmos, just from plugging in a graph on an equation on Desmos. And as you can see, you can hide an equation so you don't have to get rid of it right away. And you can view, you can even put equations in using factored. You can put a factored equation in instead of a polynomial equation in standard form. So there's your options right there, and there's Desmos for you, and hopefully this video has been useful. If you got any questions or comments, please leave them below.